right, kids. All right, last time we stopped at this. Oh, where's my pen? I'm gonna take my pen out. I had the pen out, right? So last time we stopped at this one, and I gave you orthogonal gradient theorem. Basically saying that if P naught is a point on C where it has a local minimum or maximum, we know that the gradient vector of F is orthogonal to that point C, which is very important. And that's how we could find, when you do the Lagrange multiplier, that's how we could find min and maximum. Oh, I'm going to give you extra credit problem today, too, for your exam.
Wait, you're going to give it to us today?
Yeah, so,
And with the exam?
yeah.
Nice.
Okay. Can you guys see pink? All right. Your weekend is gonna be good right before you can't do Halloween anymore because of the exam. I'm gonna make the exam so hard that you will not do any Halloween. You can't even hang out in Zoom. Who said it? You guys gonna dress up and hang out in the Zoom? Was it this class or my other class?
And like throw virtual candy at each other?
What is it on TikTok? You buy like send gift. Apparently you make money out of that. Yeah, so those live TikTok people, they make money out of that. So on the side, they have like gift. If you send gift and the gift costs money. So and if you send the gift, it could be $1 to $100.
Oh, and they get like a percentage or something of it?
Okay, TikTok keeps half of it, but still, like you just whatever you do, but those people they make money. So I'm like, wow.
That's why all the pretty cousins go on there.
Pretty cousins didn't have all. Do you guys have TikTok? Have you guys watched TikTok? Right? Only one? Or two? You just don't want to admit to it. So find the greatest and smallest that the function takes on the ellipse. Takes on the ellipse. Do you guys remember how to graph this? What is this? Square root of 2, 2, and 2, right? Square root of 2, negative square root of 2, and over here is square root of 8, negative square root of 2, 2. That's the ellipse right over here, okay? So let's look at the answer. All right. All right. We want to find the extreme values of subject to the constraint Okay. So now what do we do? To do so, we first find the values I finally watched the movie. I finished it without reading it. Well, like I went on a sidetrack. It's the Comey Rule. Has anybody ever seen that? It's on Hulu. Comey Rule. It's about James Comey, the FBI director. No, okay.
The one movie you watched was like the one I know you said.
But I was reading stuff on it on the side. His actual things like the Comey Rule. It's like the movie's like 4 hours long. No,
You just picked the wrong movie to watch.
it was good. I loved it. So yeah, yeah. You mean scroll down? I'll stop while talking about Comey.
Did you hear about the people that are trying to curse Trump on?
They're trying to do what?
They're trying to curse him on Halloween.
Curse as in like voodoo curse?
Yeah, like witchcraft.
Like actual voodoo curse? Oh, okay. I mean, how's that gonna affect him?
I don't know. He's gonna get cursed.
It's like reading those holy book. It really doesn't help. They're all the same. They're a bunch of science fiction. Did I insult half the people over here right now? Did you copy it?
It's like the original science fiction, right?
No. The original science fiction is, what was that one? Gilgamesh. If you actually read the Gilgamesh, you find a lot of similarities between his life and Jesus' life, also known as Jesus. Jesus?
No,
Gilgamesh?
no.
Who? Jesus?
You said Jesus or something.
Oh, Jesus' life. Yeah.
Jesus is like.
Yeah. Values of from the equations of these equations, we got to find x, y, and the lambda, for which and g of x, y equals 0. Okay, so let's look at the gradient equation. You know what religion I want to join? Scientology. And see what's the highest level I could get to. Like, you haven't seen that? What was that? South Park one? Go South Park one. It explained like the best way. South Park, the cartoon.
Oh, okay.
Yeah.
That's like that's just because of that.
What? Yeah. You gotta pay it to that level, yeah. You've never seen that clip, South Park, explaining Scientology? Just like 5 minutes long. You gotta watch it. I was gonna play the music video. What was this music video I was gonna play today? Oh, Tekashi 6ix9ine. Okay, I'll do it next time. I'll do it right before the exam so your brain cell dies. Gradient vector for, yeah, that's right. And then the other one is going to be lambda xi over 4 plus lambda yj. Okay? Now let's look at what's happening. So y equals lambda x over 4 and x equals lambda y. Lambda and y is kind of confusing. Do you guys see it? Upside down, but that's why I got to write the lambda kind of like this.
You know, we're getting so many symbols that I just make up my own now.
Yeah, that's what you do. Yeah. You make your own symbol.
Make like an A, then like double line or something.
I will draw a caricature on my homework problem. All right. So we have that, and from that, what can we get? Y equals what? Lambda over 4, and you get lambda y, which is lambda square over 4. And don't forget the mistake I told you about. So from that, what do you get? y equals 0, and the other one is what? Lambda equals plus or minus 2. Good? Life is good? Chris? Is life giving you trouble? Is it yes or no? See, your struggle means nothing. Your happiness means nothing. So you should feel nothing. You know I'm speaking the truth, right? Especially if you ever get dumped. Oh my God. Especially over text. I'm like, yo, bro, give me better closure. Like, what is this text?
She must have been younger than you.
What?
She must have been younger than you. She does something like that.
Yeah. I mean, I'm 59, so like anybody's younger than me. So. Case 1.
This is a different column, right?
No, it's the same problem. Case 1. If y equals 0, then x and y equals 0. But what do we know about 0? 0 is not on the ellipse. So let's look at another case.
It has to be like on the actual boundary or something inside.
Yeah, it's gonna be on the boundary. Yeah, this is where the constraint happens, right? You get this surface, and it's the constraint is right by that ellipse.
Constrained by the boundary.
Yeah, yeah. Case 2. If y is not equal to 0, implies lambda equals plus or minus 2, and x equals what? Plus or minus 2y. Oh, you missed out this coloring. Who is it? Daniel doesn't like this coloring. Well, I don't like you. This is the best insult. Like, if anybody says something, just say that I don't like you. No, I really mean it. I don't like you. You do not like this, therefore I do not like you. Substituting this in the equation, g of x, y, 0 gives, let's look at it. What was the original equation? Plus or minus, yeah. Plus or minus 2y square over 8 plus y square over 2 minus 1 equals 0. Now that gives you what? 4y over 8 plus y square over 2 equal 1. And yeah, y squared plus is that correct? The equation of, oh, sorry, I'll let you copy it. 2, yeah. Is that correct? I get y squared equal 2, so y equals plus or minus square root of 2. Did I make a mistake somewhere? Equations 2. Yeah, that's right. 2y 4 over 2.
Y squared plus y squared is 2y squared.
Aha! There you go. No, still is not correct.
If you factor out the y squared, don't you get y squared?
No, there's something is missing over here, my calculation. It's just y squared equal 1.
Yeah, because if you factor out the y squared.
Yeah, it's y squared equal 1, so y is plus or minus 1. Yeah, this is just half. But that's not my issue. My issue is over here. Did I make a mistake somewhere over here?
No, because your 4 y squared over 8 would factor back into.
Oh, not that. I'm talking about this. Did I do this calculation correctly? If you got x equal 2y or just 2?
Well, like if you plug in the y, that's 1, it's plus minus 2.
Yeah, lambda equals plus minus 2, right? So when lambda equals plus minus 2, x equals what? Plus minus 2y, yeah. Okay, so I'm doing it correctly so far, right? Okay. Then what did I do my error on? It's so fun writing with this fountain pen. Like so cool, man. I'm gonna grade your exam with this. And if you get an A again, I'm gonna use that what is that, wax seal? And you guys, so try to get all A, guys.
If you get like 100, are you gonna like roll it up for like another seal so it stays rolled up?
I didn't buy another seal. I was thinking about that.
Put the same seal on it. Then roll it up.
No, you cannot like so
I
the
need to if I know that means I get 100.
no, but I know what you're talking about. Those type of sealant, they used it. It's a completely different material.
Oh, okay.
So the one it's actual, these are called wax, and those are completely different. It was able to hold it, and then once it dries up, the only way you could open it is crack it. But these, like, you could reuse it again. You could take it out, heat it again, and it will become wax. So
Like put a ribbon on it, you send it with a pigment from a blade, like.
I mean, I like those ideas. Just give me your pigeon so I could use that pigeon to send it back to you.
What if actually
What was
you
our
have to
school fee for? It could just be for this class and then don't get a pigeon out of it?
Don't they have pigeons everywhere in Vegas? Like just like the pigeons hanging around everywhere.
I want like a nice pigeon. I didn't pay like $100+ for some street pigeon.
Wasn't the pigeon in Vegas like have a hat on them?
Really?
Yeah, because people were like,
No way. I gotta pay more attention to that. They got a hat on them? Okay. So the function f of xy, it takes the extreme value. It takes the extreme value. If y equals that, I want to make sure. What did I do my mistake on? And from x equals. Yeah, it's this is gonna be interesting. Plus. This is gonna be a really interesting problem. So plus what? Plus or minus, but I'm gonna use. First one is if. Can you guys see them? No. If x equal, I'm sorry, if y equals 1, then x equals what? Plus or minus 1. So I get my points to be 1, 1, -1, and 1. Oh, where is it? Y? Oh, sorry. Is that what you guys are talking about? Oh, 2y. 2y. Yeah, 2. Now, if y equals -1, this is going to be interesting. X equals is going to be -2 and +1. The order matters, and we'll come back to that in a moment. and then you get -2, -1, and then 2 and -1. So what are the extreme values then? So x, y, plug those numbers in. The most value you will get what? 2. And the smallest number you'll get is -2. And what combination lets you do that? This 2. And this combination lets you do that. Okay.
When does y become 2 on the 2 top one?
Oh, is it? Did I make a mistake over here? When y? Oh, it's the other way around. Okay. So it's 1. It will be 2, -2. Yeah.
So it's kind of like external, but we're doing like a constraint or something?
Yeah. So finding the order matters, and I'm gonna tell you the next one why the order matters. Finding the orders.
What do you mean the order?
You'll see. I spent extra time doing this part right over here. When y equals -1, I got -2, right? And when y equals +1, but from that, no. When y equals -1, the first number we got is -2, and the second number was +2 because of the plus and minus. And I'm going to explain to you why I paid attention to it. This right over here. Give me a little bit more time and I'll explain to you what the heck I meant by that. Lagrange multipliers with 2 constraint. Yep, right there. The order matters. Okay. 2 constraint stuff is very simple. G1. And guys, what Pokemon is this? Good job. Did you guys read the history of it, how Mewtwo came to be? It was actually a glitch that even the Nintendo people didn't know they put it in there. So yeah, so the 2 programmers, they left it alone, didn't tell anybody that. So like even the Nintendo people didn't know about that, and the glitches in those days people didn't have internet. So imagine how people found out through rumors and all that. I know. I remember I had to find Mew 3 to move the truck. You don't know that thing. It's a glitch that I spent many hours trying to figure out moving the truck by the ship. If you ever played the original Pokemon game, you know the truck. Stupid truck, man. No. It's a rumor. In those days, they didn't have computer, so they said, "Oh, you could move this truck only this way," and it's some ridiculous thing you have to do it. But it was all bullshit. It was just I spent like weeks trying to do that, and it didn't happen. I gave up. I was like, what? It wasn't a calculus problem. At least it's doable. It didn't come out of illogical things. And that's when I realized, like, never trust any rumors. It was a big lesson learned for me, so. I was 40 years old.
That's like 30 years.
Three variables. We can maximize subject to but then you get 4 equations and 4 unknown. So here it goes. You think these are hard? Actually, it's not. Let's try to. Yeah, they're not that difficult. We'll do that problem together. So let's look at it. Let's look at a classic example. Ah, forgot to bring my coffee. Darn it! I was gonna use this for the coffee thing. That's what. What? Oh yes, that's a good idea. And bring some really amazing food that smells a lot, lot of aroma in it. Make that ASMR sound. Yeah, make that ASMR video. Have you guys watched those videos? People eating food? I mean, the food looks amazing. But I don't eat at home though, so therefore I can't be that sad. That's the worst place you want to go. When it's served by the robot? Yeah, sure, why not? Then I'm the ruler of all the robots then. I mean, like, unless the robots took over us and then like the living organisms are second-class citizen. Is that what's happening? Sure. It's called evolution. Someone just did one time clap to evolution. It's like evolution, yeah.
There's a short story where mankind evolved and it's one, and at the end it's just man, it's just everybody, the entire human race is that person. And then there was a supercomputer at the time.
Oh, yeah, they have all those scientific questions. Yeah, they have a lot of books on it. Yeah. So, do you remember doing this problem in pre-calculus using 200-meter of fencing? So corals, remember? Corals or corals? How do you say it? Coral. Oh, coral reefs. There you go. There you go. Coral, yeah. That's why I said it, because they just found one of the biggest coral reef is bigger than the Manhattan building today. What? It's bigger than Manhattan building. They just found that.
If you were right next to it, you would be like the person that would, right?
No, I'm afraid of deep ocean. That's my big fear. It's like deep ocean scares the bejesus out of me. What? No, it will be dead. They can't extract it. They can't even extract Titanic. So let's look at this problem. So that's the fencing, right? To maximize the area, subject to this constraint. This is the typical problem you've seen in pre-calculus. Remember, it's corral, right? Corral. Corral. Don't they have restaurants over here? It's called corral.
Golden corral. I think it's all over the place. We should have that for dinner today.
You can technically. No, we'll do it like this. Here's the river. I mean, you don't really need to do chickens because chickens, they'll always come back to like comfort thing. Have you ever raised chicken over here? Anybody? You know, they're really friendly animals, right? Kenna? Okay, first of all, if you're afraid of chicken biting you, you should not exist. Like, you evolved to become a superior species than chicken. It's like, if that thing is biting you, just kick it, kill it. That genes needs to die off. Yeah, deep fry it. Yeah, you deep fry that too. What? Oh yeah, they do that. It's just we're not used to seeing goose, and they're cute. You've seen what is this Sleeping Beauty thing, or is that Disney movie? The goose becomes a prince or something like that, or princess. That's what.
Oh, that's an Aesop's fable. Second of all, that's not a Disney movie.
Oh, sorry. No, you make foie gras, like force feed it and get that nice liver out of that. I don't know. I never pay attention to children's cartoon. I don't know. I guess the goose becomes, I don't know. Does it become a princess or a fairy?
You know, there's this goose and it lays eggs and it's gold, and then the farmer's like, look, I'm going to make a profit off these golden eggs. And then she's like, you know, if I kill this, I can get all the golden eggs.
Yeah.
But like, it's not golden eggs, it's just a goose.
So Disney ever made a movie like that?
No.
Okay, then I don't know what I'm talking about. All right, so let's look at it. So the gradient vector in this case is what? Yeah, three-sided fence. This is a river. So the gradient vector in this case becomes yi plus xj, and then you get what in this case? 2i plus 1j. Okay, and then y equals lambda 2, x equals lambda. Is that correct? Yeah. So 2x plus y equals 200, and then when you plug in the lambda, for lambda equals 200 and lambda equals 50. So since lambda equals 50, x equals what? 50, y equals 100. And the area you get out of that is 5,000. Now let's use.
It only gave us the maximum point.
Yeah, because we want to maximize it.
But it didn't give us like more points. Is that something that might come out at some point? Like, do you know what I'm trying to say?
Yeah. You should get more critical. Well, in this case, you got only one critical point. That's it. So it doesn't have minimum then. If you would technically graph it, it wouldn't have any minimum, given that constraint.
2x plus y.
Yeah, equals 200. Has anyone ever eaten goose before?
Minimum would be like negative.
Yeah.
Have a max at 200.
And it stops that if you do it. Has anyone ever eaten goose before?
I think
No?
I have.
You have.
I don't think it's very memorable because I don't remember that.
But you ate their liver though, right?
Oh, livers are the best.
Yeah.
Hearts?
The goose liver?
Oh,
They're,
hearts are good.
it's hard. Like most places, they don't know how to prepare it. Like the giblets or the exotic part of them. Okay.
Go to like
Japanese tapas place or a Mexican. Yeah. Cuts the cylinder. So here it is. You have the cylinder right over here. And the plane kind of cuts it off. In an ellipse. Find the points on the ellipse that lie closest to and farthest from the origin. So let's look at the problem. Are you still copying it?
on the exam, are there going to be any kind of like,
That's a good exam question. I'm just gonna give you like this.
yeah, no, like, do we need to know like any shapes of functions? Other than normal ones?
Yeah, normal ones, yeah.
Like ellipse, circle,
We're not gonna ask you to find this cross-blade until you cut it.
or like,
Yes, I'm gonna do that just for you. Like you're gonna have individualized question. The more I hate you, the weirder the question is gonna be, and the weird shape it will have. I'm gonna ask you, give me the maximize this like the biggest sphere you could make inside this dodecahexagon.
isn't that like one of the hardest problems on a,
Huh? Whatever. Now I decided to do a hexagon, whatever that is. Yeah, sure.
he's going to invent a shape just for you.
I can't name it after like octagon. After that, what is it? Hepta, then hexa, right? Hepta, hexa. Wait, how does it go again?
So it's hexagon, hexa, then hepta.
Hepta is in 7?
Then octagon,
Octa.
which is 8, then nonagon, which is 9.
Okay, there you go.
Monogon.
And what about 10?
Decagon. Like a
Decagon.
Decagon?
That makes sense. So cool.
That sounds quite reasonable.
What? Decade is 10 years. The, wait, you guys didn't write paper on it like 4 years, some scores ago, the like Abraham Lincoln thing? No, not that. Yeah, Gettysburg address, yeah. All right. So let's look at this. Why am I using this? So let's look at it. The square of the distance from XYZ to origin subject to these are the two constraints we have.
squared plus y squared plus z squared, is that something that we would come up with? Or is that given?
No, I'll give you that. I'll give you that in this case. Yeah.
That's what is that? Is that the cylinder?
Well, yeah, that's the cylinder in the third dimensions. But I'm thinking right now, how would we go about? If I draw.
You do it for like both of them and then find which point.
Yeah, but I'm thinking right now because the better way of doing that would be, yeah, if you graph this, this is what the cylinder would look like. Can you graph it x squared plus y squared plus z squared? What is it equal? Let me see.
I can only do two variables, yeah. Yeah, I can't graph in 4D, so that would be 4D.
Yeah, no, this is something else then. Yeah, because yeah, it is the fourth.
That is 4D, yeah. I can do x squared plus y squared.
Well, maybe x squared plus y squared plus z. No, if you set x squared plus y squared plus z squared is equal to 1. The plane is that. Yeah, that is something that I have to give you this. Yeah. Yeah, that's something that I have to give you. The function f, I have to give you that. Okay. So now let's look at it. So you get 2xi plus 2yj plus 2zk.
The two multipliers, they can be different or the same.
Yes, you have to separate them. From that, let's combine all the i's. And the j's. So from that, we could say 2x equal mu lambda 2x plus mu, and then 2y equals lambda 2y plus mu, and the last one is 2z equals mu. Now, this is a little bit tricky one. Yeah, we gotta do it this way. So 2x minus lambda 2x minus that, yeah. Two x minus 2 lambda x plus 2z. That's what I'm doing. From that, I can factor out Oh, sorry. From that, I could factor out 2x 1 minus lambda 2z, and I could cancel out this. And the other one, 2y equals 2y 2 lambda y plus 2z. From that, oh, let me do it this way. Now you could see it. You could factor out y. 1 minus lambda equals z. That was the crazy algebra part. Okay? Yeah. Now the order matters. You will see that. If either lambda equals 1 and z equals 0, or lambda does not equal 1 and then what happens to the equation? X equals y, which equals z over 1 minus lambda. You have these two equations going on. So lambda will equal 1 or not 1. If it equals 1, z equals 0. If it doesn't equal 1, then x equals y, which equals z over lambda. Now let's look at what's happening over here. If z equals 0, which means lambda equals 1, you get what? X plus y squared minus 1 equals 0. And x plus y plus z minus 1 equals 0. So if z equals 0, what happens next? So what are the points you get on the ellipse? If z equals 0, what are the points you get? And you could do that, solve for that, and from that you'll get 1, 0, and the other one is 0, 1, 0 on the ellipse.
So 1 is coming from where? So 1, 0, 0?
1, 0. So if z equals 0, you get x plus y minus 1 equals 0, and then x squared plus y squared minus 1 equals 0. From the system of linear equations, that's what happens. And then we want to pick the points that those are on the ellipse. If it's not on the ellipse, we're not going to pick those points. Now, these are not that important because this is not going to help us. But if x and y equals each other, then what happens? X plus y squared minus 1 equals 0. X plus y plus z minus 1 equals 0. Then right over here you get what? X plus z minus 1 equals 0, which you get z equals what? 1 minus 2x. So that's what I have. And then x squared plus y squared minus 1 equals 0. I get 2, I'm using x, yeah, 2x squared equal 1. So x equal plus or minus 2. So plug this information right over here, and you get what? Now here's the tricky part. Z equals 1 minus plus 1 over 2. Pay attention to this part. The order for minus plus matters. Now let's find the corresponding points. What? One minus this divided by that, and then I took a square root of that. Yeah, because when you plug in the positive first, you get the negative, and then when you plug in the negative next, it becomes positive. Yep. So if I'm using positive square root of 2, comma, positive square root of 2, what's the point I get right away? 1 minus, that's the negative one. And then the other corresponding points, if I use this negative root 2, I get 1 plus root 2 over 2. So from that, I'm going to give you some verbal explanation for it. Be careful. Although P1 and P2 both give local maxima of f on the ellipse, P2 is farther from the origin. Than P1. So the points on the ellipse closest to the origin are 1, 0, 0. And you know the distance, the length of these two are the same. And the farthest All right, so let me give you the problem. No, because that's not the farthest. It's still closer. All right, let me give you the exact. That's all I'm going to tell you. And on the day of the exam, you bring your paper, you submit it with your exam, okay? Oh, you're still copying it? What? Just open.
We're going to write down the
Question? Yeah. I'm gonna tell you to do a crime. In order to get the extra credit, you have to do criminal activity. Can you do it? You're like 14. Are you even legal to do any crime? Huh? Oh, are you? Do they let 14 years old vote now? We're so liberal. All right, kids, ready? All right. I'm going to give you very few instructions. That's all I'm going to tell you. Rob a bank. The fence there is a fence 2 meter high, because we're Europe, we use metric system.
The US system is stupid.
So I'm making an international crime?
Yes, in this case, yes. Or if you go to that one city in Arizona where they use metric system for that, like there's a road in the city. How it came to be was America was about to become all metric system under Carter, and they experimented on that, and Carter lost the election, and Reagan came in, and we never converted to metric system. If Carter would have got elected, we would have all converted to metric system. What? Actually, when you travel, yeah, because when I'm traveling, there's 10 kilometers. I'm like, what the hell like, how far is it? Like, let me try to understand it. So, away from the building. What is the shortest ladder you will need? That's it.
Fence 2 meter high, 1 meter away from the building. So we're trying to get.
You're trying to rob the bank. Yes. That's all I'm gonna tell you. I'm not gonna give you any more instructions. It's all in here. You gotta.
Can you climb over the fence and then walk?
You cannot, like, if you want to use that as an answer, sure. If you want to do that, but are you gonna get credit for it? We don't know yet. Are you guys good? Okay.
What if I instead actually go rob a bank?